Hello bachcho, let's read the question. So the question says diffraction of light. The diffraction of light takes place when an object or obstacle comes in the path of light. In this phenomena, bending of light takes place around the edge of the obstacle. The bending of light from its path is larger when the size of block or the obstacle is comparable to the wavelength of the light. If we place a narrow slit in the path of the wavefront of light, then bending of diffracted wavefront will be more. The diffraction of sound waves also takes place. For visible light, diffraction can happen when the object of lambda is equal to 10 to the power minus 6 meter order comes in its path, in which case diffraction of light will be more for an aperture D. So, to understand the question, let's draw a diagram. Okay, so or we can see the above given diagram. So we have this slit, focus on this slit here. Okay, so in this slit, when primary wavefront or incident wavefront comes and collides with the edges of slit, these edges now themselves uh, act as secondary source of wavefront, and thus the propagation takes place. Now these are secondary wavefronts which are going away from the slit, these which I am highlighting now. And this now let's understand the key concept first. So the key concept behind this question is the necessary condition of diffraction. So, what is the necessary condition for diffraction? It is that the aperture of slit must be comparable to the wavelength of light, as it is written here, comparable to the wavelength of light, and hence our key concept becomes D must be comparable to lambda. Okay, now the question asks us in which case diffraction of light will be more for an aperture D, and options are given in the terms of D and lambda, that whether D is greater than lambda, D is comparable to lambda, or D is less than lambda. Now we can see that if the D becomes larger than lambda, then the wavefronts will be not quite clear, as the secondary source of wavefront will be farther than expected, and hence option A is not a correct option. Now let's check option C first, because option D is already what we know from our key concept. Now option C, D is less than lambda. So what will happen if D is less than lambda? It says that slit distance or aperture between the slits is less than the wavelength of incident light, and hence we can see that the two secondary source of new wavefronts are closer than they are expected, and hence the new secondary wavefronts will be quite clear than the incident wavefront, and hence the diffraction of light will be more for aperture D when D will be less than lambda, and hence option C will be correct option to this solution. I hope you understood it well. Thank you.